Hello everyone. In this session we are going to see one example problem. Let's see what is that. So there are two switches for start and stop the lamp. By following the below condition, write the ladder logic program. So we are having two inputs and one output. Fine. And when the start switch is, this is a switch, not a push button. Fine. So when the start switch is 0, lamp is 0. That's fine. First condition is 0, 0. When the start switch is 1, lamp should on. When the start switch is 0, lamp should remain on in this state. Again it is on, lamp is 0. Like that, input is having multiple states and output is also changing for each state. Correct? Can you see? So whenever you are having multiple states of input and output for the same program, you should have the concept called memories. Fine. So without memories, we cannot able to solve this problem. So I hope you have remember our memory sessions. What we have seen. So by using memories, we will be storing the state of start switch in coil, memory coil, right? So we will be storing this, like that. We need to store all the states of inputs. And in the last rung, we will be, joining all those memories in one rung to establish this outputs, corresponding outputs. Fine. So let's see how many memories we need to use. For the first condition, there is no need because 0, 0 is the normal one before starting the program. Fine. Yeah. So start counting from this place. This is 1 and this is 2, 3, 4, 5, 6, 7, 8. So 8 memories we need to use. So each and every memory is storing the corresponding. For example, this is M0 means this M0 is storing the state of start switch. And M1 is storing 0 state of start switch. The one important thing here is sequence. Fine. So this one state here, the start switch is enabling. No, this is not equal to this one. Why? Because this is the first step, this is the third step. And same, this is not same one because this is third one, this is fifth one. And this 0 and this 0 is not same one. Same, this 0 and this 0 is not same one because start switch is pressed in a sequential manner. Like first it is turning on, then it is off. Then it is turning on, then it is off. Like that they are doing toggling. Okay, so for each and every toggling, we need to show the corresponding lamp status. Got it? So for that only, we need to store all the states in corresponding memories. Right? So first we'll start with this one. We'll store the status of start switch here. In M0 first. Right? So let's do that. So totally here 4 toggling happen. See 10 10 10 10. Let's see how to do this in a software. So just go to our software page. Now take this one as a start. Right? So just type START and this is the switch which is going to change hereafter. Fine. And include your stop switch also. Just a minute. Got struck. Yeah. Just delete this. Click on this and just type I:0/1 which is our stop. Fine. And here whenever the switch is going to turn on for the first time, I'm going to store that in memory. So I'm going to use the memory coil and I'm going to name that as M0. Okay. So we need to latch here, and why we need to latch, that and all we have discussed in the memory session. If you couldn't able to recall that, just go to that session and just see why we are doing the latching here. Okay. To follow the sequence. Fine. So let's go to the second rung. In this rung, our switch is going to be in the off condition, right? So you need to use normally closed contact R of our switch, and this state I'm going to store it in M1. So use some different memory B3:0/1 which is our M1. And this fellow also need to be latched. Fine. So latching is very, very important. If you are not doing the latching, you cannot get the output. Got it? And so how to connect the first rung with the second rung? Yes, we need to have the previous output. So like this, you need to give this is step 1, this is step 2. Like that you need to give. Fine. So let's go to third rung and just copy this. Yeah, just we'll type from next rung, we will start copying. Fine. So here, and the previous address, previous output, and your start, because here in the third step your start switch in a on condition. Fine. And this is gonna be your third memory, so name that as M2. Fine. So here also we need to have a latching. So latching of your new output. I need to have one normally open coil. After that you can drag and place the address here. Fine. So 1, 2, 3 is done. Just see the PPT. See here, this is 1, this is 2, this is 3. All 3 are done. Now again we need to do for 0. So for that I am going to copy this rung and just paste it here. So now you need to use the previous memory and your start switch, and this is gonna be your new memory. What is your new memory now? Which is M3. Yeah, M3 it is. Just keep it over here. And the next rung should be this one. So you can pick and place from the reduce the time, you can do like this. So this is gonna be, because we are going to repeat the same steps whatever we have seen before, right? Nothing new we are doing. That's what I'm just copying from that place. So this is gonna be your M4, and M4 should be your output now. Fine. So all the 5 steps are done. Now the 6th one should be this one again. Keep it here. This is your previous memory, and this is gonna be your new output, which is M5. Fine. M5, and keep it here. Fine. And what next? This one. Just copy and paste. But whenever we are pasting, you need to change the address. Fine. It's gonna be this one, and this is gonna be your new memory. With 6. This is M6. Keep it here, M6. Fine. So what next? We are going to have only 2 more rungs. One for the last memory, another one is for the output. Got it? Yeah, I think M1, M2, this one is M2. Yeah, fine. So we are going to have one more rung, which is the normally closed contact of our switch, because our switch is in 0 condition. I mean closed condition. That is whenever it is going 0. Fine. So that's what I'm using the closed input here. So this is gonna be your new output, I mean new memory, which is M7. Fine. The same thing is going to be here. So totally how many memories we have planned? Totally 8 memories, right? So 8 memories are here from M0 to M7, right? So the last rung is the main one. Fine. Because in the last rung only we are going to have our output. What is our output? O:0/0, which is my lamp. Fine. Just type lamp. And now we need to have when your lamp is turning on for the first time, when it is going to off, like that. Fine. So let's see when it is going to on for the first time. See, for the M0 memory itself, it is turning on. And when it is turning off for M0, M1, M2. For M2, it is turning off. right? So just type M1, M0. For the first memory, it is turning on. You just change the address. This is the first memory. Whenever you are turning on, lamp is on. For the next memory also, it is in an on condition. So there is no need to connect this M1 here. When it is turning off, M2. So normally closed contact of your M2. What is the address of M2? It should be B3:0/2. Fine. So when it is turning on again means for the next memory it is turning on. So I am connecting the normally open contact in a parallel to the place where it got broke. So now here I am typing B3:0/3. This is M3. Can you see here in the PPT? 1, 0, 1, 2, 3. See here it is turning on. Fine. For 4 it is turning off. 5 remaining turning off. 6 it is turning on. So put a 4 here. 4 here. For 4 it is turning off. So I am putting a normally closed contact in a series. Again for 6 it is turning on. So I am opening a branch parallel to the break where it got broken. Correct? And here I am connecting my 6th memory. Fine. 6 I have connected. Now check the status when it is turning off for the last time for M7. So for M7 I need to connect it in a series. Fine. So just check for errors. There is no errors. Let's check how it is working. Fine. So first save your program. Fine. Go for download. Go for monitor. Run. Fine. Shall we do this now? So let's recall this first. Whenever you are turning on, your output should on. Fine. I'll use this. I'm turning on. Output is on. Fine. If you are turning off, output remains on. That is the second point. Correct. So now whenever you are turning on for the second time, output should off. Let's see that. You are turning on, output off. You are again turning off, output remains in on condition. This one. Okay. Fine. Now, if you are turning on again, output is off. If you turn off, it remains in off condition. When you turn on again, it will on. When you do the last one, it will off. This is M7. Can you see one by one your memories are in a on condition, right? So in between, whenever you press stop, everything should go off, no? Yeah, all the memories are going off. Fine. We'll do from the beginning once. For that, we need to follow this sequence properly, okay? We'll do one thing. We'll take one pointer. This is 0, 0th memory. This is 1. This is 2. This is 3. This is gonna be the 4. This is 5. This is 6. And this is 7. Fine? Got it? So let's see this. I'm turning on for the first time. Your output is on. Fine? 0 and this is gonna be the 1. For this, output remains on. For 2, what should happen? Output is off. Just see here. For 2, for 2 output is off. Got it? Now I am going to do the 3. For 3 output is on. For 4 output is again off. Let's see that. For 3 output should on. This is 3. Output is on. For 4 output is again off. Correct? So let's see what is for 5. For 5 output remains off. For 6 it should on. For 7 it should again off. Right? So let's see. I'm going to do for 5. Output remains off. For 6 output on. For 7 output off. Got it? So it looks complex. It looks like a big program, but it is very easy because we have done the repetitive process. Like repetitive rungs we have used. Whatever concepts we have put it in a first and second rung was repeated again and again for the fourth and sixth rung, fourth, fifth, sixth, seventh. Everything is repeated. Got it? So this is one important example that we can understand memory concepts more. Got it? So whenever we are pressing the stop, everything will go off. Fine. So this is the importance of stop switch. Got it? So just practice this in the software. If you have any doubts, put a comment over there. Fine. I'll meet you in the next session with another example. Thank you.